Hello students, welcome to lecture 11 of chemistry online classes. We were solving the numerical questions on the mole concept. Some 9 questions together we have solved in class, and I have given 4 questions as homework. Very simple 4 questions I have given you as homework. The first one was, what is the molar mass of a gas if 1 liter of gas weighs 1.5 gram at 273 K and 1 atmospheric pressure? 273 Kelvin and 1 atmospheric pressure is called as STP, and they said 1 liter of gas has weight equals to 1.5 gram, but at STP the volume occupied by 1 mole of a gas is 22.4 liter. So 22.4 liter of a gas has weight equals to what? Just cross multiplied 22.4 into 1.5, that equals to 33.6 gram. So you can say the molar mass of the gas equals to 33.6 gram per mole. So we are using this constant 22.4 liter because that is equals to 1 mole. It means that is gram molecular mass of gas, and it means Avogadro number of molecules. We are not asked molecules, but this 33.6 gram per mole means it contains Avogadro number of molecules of that particular gas. The another one was, how many atoms of oxygen are present in 300 gram of calcium carbonate? So number of oxygen atoms is equal to number of moles into Avogadro number, but that gives us the number of molecules. They ask atoms, so multiply by number of oxygen atoms in 1 molecule of oxygen, 1 molecule of calcium carbonate, 1 molecule of CaCO, calcium carbonate, and this number of moles can be written as mass by gram molar mass, Avogadro number, and number of oxygen atoms in 1 molecule of calcium carbonate is 3, because calcium carbonate contains 1 atom of calcium. 1 molecule of calcium carbonate contains 1 atom of calcium, 1 atom of carbon, and 3 atoms of oxygen. So this weight equals to 300 gram given. The gram molecular mass is 100 because calcium has atomic mass 40, carbon has 12, and there are 3 oxygens. Means 3 into 16, which is equal to 48, and that happens to be 100. Multiplied by 6.02 into 10 raised to 23 Avogadro number, multiplied by 3, 300 by 100 is 3, 3 into 3 9, 9 into 6.02 into 10 raised to 23, we get this answer 5.4198 into 10 raised to 24, because what we get is 54.198 into 10 raised to 23 plus 23. So we shifted this decimal point from this to this place, and we added 1 power to the 10, and it becomes 23 to becomes 24. The next one was find out the volume of the following at STP. The first is they have given 14 gram of nitrogen. We know that number of moles is equal to mass of that gas, gram molecular mass, and also number of moles is equal to volume of gas at STP divided by 22.4 liter. So this V equals to this W multiplied by 22.4 divided by GMM, gram molecular mass. This W is equal to 14 given in the question. 22.4 is the constant here. Gram molecular mass is of nitrogen is 28. 14 plus 14, 28. This is 1 by 22.4 by 2 is 11.2 liters. The other is 6.023 into 10 raised to 22 molecules of ammonia. So that molecules they have number of molecules. So number of moles is equal to number of molecules by Avogadro number equals to volume in liter divided by 22.4 liter. V equals to number of molecules into 22.4 divided by Avogadro number. Number of molecules they have given question 6.022 into 10 raised to 22. 22.4 divided by Avogadro number. This 6.022 6.022 get cancelled. This is 10 raised to plus 22 multiplied by 10 raised to minus 23. That becomes 10 raised to minus 1 into 22.4 is 2.24 liters. And this last one as the 0.1 mole of sulfur dioxide. So N equals to V by 22.4, V equals to N into 22.4. Number of moles directly is 1.1 into 22.4 equals to 2.24 liter. I hope that you have already solved these questions and you also obtained the same answers. If you are not getting the same answers, solve it once again. I have explained now how to solve this, and if you try again and again, definitely you will get this type of questions more accurately. Right. Now one more homework I have given. The space was not sufficient, that's why I have not solved this. Now we will solve this. The last one, question number 13. In that, we have to calculate the atoms of each type in 33.42 gram of sucrose. So we can say number of carbon atoms. We'll take first number of carbon atoms is equal to, first we'll see the number of molecules, Avogadro number, number of moles into Avogadro number, and then we write here number of carbon atoms in one molecule of sucrose, which is C12H22O11, table sugar we call it. Now how many moles are there? This can be replaced by mass by gram molar mass. This is Avogadro number. And one molecule of sucrose contains 12 carbon atoms. So multiplied by 12. So mass of sucrose is 3.42. Gram molar mass is 342. 6.02 into 10 raised to 23 is Avogadro number. Multiplied by 12. So this is 3.42 multiplied by 100 is 342. This is 100. So this is 10 raised to plus 2. We'll make it minus 2. And that's why we have 6.02 multiplied by 12. So we can write this as 72.244 into 10 raised to 21, right, atoms. This many atoms are there in 3.42 gram of the sucrose. 264 it is, right, 264. Similarly, we can calculate here number of hydrogen atoms. Number of hydrogen atoms, that equals to N into Avogadro number. that will give us the number of molecules in 3.42 gram. But they ask number of hydrogen atoms by calculating. So we can say number of hydrogen atoms in one molecule of sucrose. This is 3.42, 342. Number of hydrogen atoms are in one molecule 22. So you can just see these calculations. It is 1 by 3.42 by 342 is 1 by 100. So it is 10 raised to minus 2. You can multiply that. But ultimately, what answer we get is 66.242 into 10 raised to 21 atoms. So I hope that you are getting the same answer. 66.242 into 10 raised to 21 atoms of hydrogen. Right. The next one is number of this hydrogen is 22, so this number is 132.484. Right. Now number of oxygen atoms is equal to number of moles into Avogadro number, and then number of oxygen atoms in one molecule of sucrose. 3.42 into 342 multiplied by 6.02 into 10 raised to 23, and one molecule of sucrose contains 11 oxygen atoms. So you can just simplify this, and now we get 66.242 into 10 raised to 21. If you have written 6.624 into 10 raised to 22, that also okay. So it contains more hydrogen atom, then comes carbon atom, and then oxygen atoms, like that. Because formula is C12H22OH. So these are the few questions on the whole concept around floating we have solved. Solve these questions once again, and MCQs also simultaneously we solve, and this concept will be more clearer to you. Now we have to go ahead in the theory part. We have to learn about the empirical formula and the molecular formula of a compound. Empirical formula and the molecular formula. These are the two things, but before that we'll define what we mean by formula. It is the symbolic representation of molecule of the compound. For example, we have taken the beaker, and in that we have taken the water sample, and we want to express this water in the form of chemical symbol. So this is written as H2O, and that is called as the formula of water molecule. Because it is a symbolic representation, we are using symbols of the element. And what we are representing? A molecule. And this molecule is of which compound? Water compound. You are understanding this? If we take 18 milliliter of water sample, how many gram of water it is? Density is equal to mass by volume. That's why V is equal to M by D, or M equals to, we want to calculate M, V into D. Density of water is 1 gram per milliliter. So it is 18 gram. 18 gram water means how many moles? 18 by 18. Mass by molar mass. 1 mole. How many molecules? Number of molecules is equal to number of moles into avoided. 1 into 6.02 into 10 to 23 molecules. How many hydrogen atoms? 2 are there. 2 into 6.02 into 10 to 23 atoms of hydrogen. How many oxygen atoms? 1 oxygen atom. 1 into 6.02, 2 we can write on 0 to just into 2 10 to 23 atoms of oxygen. So this formula is very important, because formula which tells us what type of molecule is present into it, and in that molecule how many atoms are present and what is their ratio, right? So formula is a symbolic representation of molecule of the compound. How to establish the formula of molecule? We call it as the molecular formula. We call it as the molecular formula. How to determine that? This part we have to learn, of course, theoretically. So before this molecular formula, there is one another type of formula which we has to determine, and it is called as empirical formula. Empirical formula. What is the difference between empirical formula and molecular formula? It is the empirical formula is the simplest formula which represents relative number of atoms of different elements in a molecule of a compound. See the definition. It is the simplest formula. It is the simplest formula. And what it represents? Relative number of what? Of atoms. Where these atoms are present, these atoms are of different elements. They are present in a molecule of a compound. Like that. So there are atoms of the elements. They are present in a molecules of a compound. This is the way in which we have to represent this. So simplest formula which indicates relative number of atoms of different elements present in a molecule of a compound, and that is called as the empirical formula. Now how molecular formula is different than empirical? See the definition. It is the formula which we can say, to be precise, we'll use this word that it is the true formula, not simplest. We'll use this word true formula. I will explain what we mean by true and what we mean by simplest formula, which represents actual number, not relative number. This word relative we have replaced with actual number of atoms of different elements in a molecule of a compound. So this is true formula. This is true formula. See the keywords here. This is true formula. It represents the actual number of atoms of different elements of a molecule of a compound. Right. So if formula is simplest and represents relative number, it is empirical. And if formula is true and it represents actual number, it is molecular. Example: the molecular formula of benzene is C6H6. What would be the empirical formula? Relative number. There are 6 atoms of hydrogen, 6 atoms of hydrogen. Means for one carbon atom, there is one carbon atom of hydrogen. So empirical formula will be only CH. Or C6H12O6, glucose. For 6 carbon atoms, there are 12 hydrogen atoms and 6 oxygen atoms. So the relative formula will be CH2. For 1 atom of carbon, 2 atoms of hydrogen, 1 atom of oxygen. Hydrogen peroxide, H2O2. For 1 hydrogen atom, 1 oxygen atom. So it is HO, right? So empirical formula is the simplest formula which represents the relative number of atoms of different elements in a molecular compound. And molecular formula is a true formula which represents actual number of atoms of different elements in a molecule of a compound. The molecular formula is actual formula, but before that we are learning empirical formula, because empirical formula is first determined and then the. Now how this determination occurs? For determination of empirical formula, molecular formula, for determination of empirical formula and molecular formula, percentage composition of elements is determined. So percentage composition of the element is first calculated. And what is the percentage composition of element? Percentage of element is equal to mass of, we can say, element in the compound divided by molecular mass of compound multiplied by 100. This is the formula. This is to be first determined. Then empirical formula is determined. And then molecular formula is determined. So percentage of element is nothing but mass of element in the compound divided by molecular mass of compound multiplied by 100. We'll see by taking example how this percentage of element is determined. So we'll take one question here. Calculate percentage composition. Calculate percentage composition of calcium nitrate. Calcium nitrate. This is calcium nitrate. And we have to calculate the percentage composition of every element. Three elements are there. One is calcium, another is carbon, nitrogen, and third is oxygen. So first we will determine the molecular mass of calcium nitrate. It is the sum of atomic masses of all the elements. So it is atomic mass of calcium plus 2 into atomic mass of nitrogen plus 6 into atomic mass of oxygen. Calcium is 14, they will give in the question. 2 into 14 plus 6 into 16. It is 40 plus 28 plus 96. 6 plus 8, 14. 1, 10, 12, and 4, 16. So it is 164. We can write this as gram per mole is the molecular mass of the calcium carbonate. Now we can calculate the percentage of every element present in it. So you can say percentage of calcium is equal to, what is the contribution of calcium in this 164 gram? It's 40 gram, because that is its atomic mass. So it is nothing but 40 divided by 164 multiplied by 100. Percentage of nitrogen. What is the nitrogen contribution? 28 by 164. Because in this 164, this is calcium, this is nitrogen, and this is oxygen. Percentage of oxygen is equal to 96 by 164 into 100. Simple calculations these are. 24.4 17.03, we can just round it off. And 58.6. When we add all these three, it should be 100%. Percentage of oxygen also can be calculated as 100 minus percentage of calcium plus percentage of nitrogen. That also another way. But as we are using formula, we have calculated in this way. So these are the percentage of various elements in a molecule of a compound. Yes, write this. This also a type of question frequently asked in the examination. Maybe they will change molecule, but percentage of element is quite frequently asked question. Determine percentage of water of crystallization. Next question. Determine percentage of water of crystallization, comma iron, comma sulfur, oxygen in pure ferrous sulfate. Formula is FeSO4 dot 7H2. This dot 7H2O, this H2O is called as water of crystallization. And we want to know its percentage, iron percentage, sulfur percentage and oxygen percentage also. So first thing is molecular mass of FeSO4.7H2. It is nothing but atomic mass of iron plus atomic mass of sulfur plus 4 into atomic mass of oxygen plus 7 into molecular mass of H2, because H2 is present here in the morning. Atomic mass of iron is 56 plus 32 plus 4 into 16 plus 7 into 18, and that happens to be 56, 32, 64, 126, and this is 278 gram per. Now next part is very simple. We have to calculate the percentage of water of crystallization, percentage of iron, percentage of sulfur, and percentage of oxygen. We can say percentage of water of crystallization. What is the contribution of water of crystallization? 126 divided by 278 is the molar mass into 100. That happens to be, yes, you also do your calculation, 45.32. Percentage of iron 56 divided by 278 multiplied by 100, that is 20.14. Percentage of sulfur is 32, 278 into 100, 11.51. No need to write percent here and second because percentage already written. And the last one, percentage of oxygen. Oxygen is 64. 4 oxygens were there. 278 into 100. and that happens to be 23.0. Right. So this is the way in which percentage of element can be calculated. Complete this question. See the next one, question number 3. It is found that it is found that 16.50 gram of metal combines with oxygen to form 35.60 gram of metal oxide. Calculate percentage of metal and oxygen in a compound, in that oxide. So we can say they asked us to calculate the percentage of metal. First we calculate mass of oxygen in metal oxide. This is the metal oxide mass and this is the metal mass. If we subtract mass of metal oxide minus mass of metal, that will give the mass of oxygen, because in metal oxide there is only metal and oxygen. This happens to be 19.10 gram. So you can say percentage of metal. Metal is 16.50. Metal oxide is 35.60 multiplied by 100. And percentage of oxygen is equal to oxygen 19.10 35.60 into 100. This is 46.3 and the remaining 53.7. These are the answers we'll get here. Right, because in metal oxide there is presence of metal and there is presence of oxygen. One more question I will give you as homework. Let's see how you solve this. Simple question relatively. Hydrogen and oxygen are combined in a ratio of 1:16 by mass in hydrogen peroxide. Calculate percentage of hydrogen and oxygen in hydrogen peroxide. Yes, this is the homework for you. Write this question carefully and see how you can solve this question. All these questions are important. Many times I have told you questions have been asked in theory as well as in MCQs. So this is about the percentage composition of the element. Now we'll try to find out how to determine the empirical formula and molecular formula. Determination of empirical and molecular formula. So there are certain steps. If we follow that, we'll first get empirical formula and then we get molecular formula. I will explain the steps. We apply the steps and we calculate. The steps can be understood only by application. But first we'll make the list of steps so that it is easy to apply them. First is determine percentage composition of elements. This is done by this method. It is given in the question. Percentage of carbon, percentage of hydrogen, different elements, what percentage they are present is given in question. Next thing we need is the atomic mass. Atomic mass of element. Third thing, we have to calculate relative number of atoms. Relative number of atoms. This is calculated by dividing percentage by atomic mass. This is percentage in step 1. Step 2 is atomic mass. Percentage by atomic mass, relative number of atoms. Fourth is simplest ratio. How to calculate this simplest ratio? Relative number of atoms. Relative number of atoms, which we have determined in step 3, divided by smallest number in step 3. For different elements we get different numbers. We have to select the smallest number, and to every relative number of atoms we have to divide by smallest number. But actually we do understand this. First we will just note down these steps. Fifth is simplest whole number ratio. This simplest ratio is to be multiplied by integer, and we get the simplest whole number ratio. In step number 6 is this empirical formula is equal to symbol of element is written and to the subscript means like this. See, this 6 is subscript to this carbon. Simplest whole number ratio, that number is written. So first 6 steps are to be followed to calculate the empirical formula. 7th one is calculate empirical formula mass. Molecular mass, this may be given in the question. 9th one, molecular formula is equal to empirical formula multiplied by this small n. This is the thing which we want to calculate, molecular formula. That equals to empirical formula into n. But what is this n? This n equals to empirical formula mass divided by molecular mass. So first we calculate n and then we write this molecular formula. And when we substitute the value of n, we get the molecular formula from empirical formula. So even though this seems to be difficult while reading, this sequence of steps we need to remember to calculate determine the empirical and molecular formula. We will take enough practice of this. You should not worry about this. But try to remember this sequence so that we can apply it in a correct way. So whatever numericals we have solved till now, you make the separate notes of those numericals. More numericals we are taking because that's how the syllabus is. I have not taken excess of numericals and I have not taken less numericals also. Whatever required, that I am taking for time being. We can add more and more numericals when we meet physically in the classroom. So that is different thing, but this is the minimum number of numericals you should solve, right? So thank you for watching this video.